Well, I'm not quite sure that I know what to add after hearing these presentations. I guess one thing is I hope no one saw my ears burning when Kanji was talking about big companies running for their lives, because we are a big company, and hopefully we don't see ourselves in that situation. We spend a lot of time sort of trying to recreate the way we do business on a regular basis. GE is a big company. We've been around since the late 19th century. And so, and it's a company that just continues to change and evolve and morph into something that is hardly recognizable when I think about it, even when I joined just a few years ago. I guess just a couple, and I'm not even sure I'm going to use this pitch. But maybe I'll refer to a couple of slides here. First, this notion of the evolution of R&D models. We really have seen a tremendous change in the way we do research and development within GE in the last 20 years. If I look back to the end of the 19th century through the 1950s, when Thomas Edison invented the light bulb, R&D was done in a very hermetic, closed environment. What you did is you found the smartest people you could find, and you threw them into a room and said, please solve this difficult technological problem. And that was the model for many, many years. But the world has really changed today. And at GE, we've really changed the way we do innovation. Some people call it open innovation. Our CEO, Jeff Immelt, published an article in the Harvard Business Review called Reverse Innovation, where he talked about how we've changed the way we do business on the R&D side. And why have we done that? Well, there are a few things. One, the development of the internet, the fact that as an infrastructure essentially allows us to share technical information across geographical boundaries, which was something that was not possible to do 25 years ago. And so the concept of having 4 research labs distributed around the world working on the same project was just not possible prior to the internet. And now we really are in a situation where we can have seamless innovation teams, some working in one geographical location, some in one other one, working together. Another thing that has really changed the way we do our R&D is where our customers are. 50 years ago, most of our customers were in the United States. Most of our employees were in the United States. Today, we have 300,000 employees spread around the world, and only a third of them are in the U.S. today. A third are in the Europe and Africa region, and another 100,000 employees are located in Asia. And why have we done that? Well, who are our customers today? Where's the growth in the markets that drive growth for our company? And they're in emerging markets. 2/3 of the growth in sales today at GE is outside of the United States and Europe. And we have to be mindful of the needs of our customers in those new regions. And we can talk about Brazil, we can talk about China, we can talk about India, but we can also talk about Africa, because Africa is growing at 6% right now, and that's a lot faster than Europe and the United States is growing. So there are tremendous opportunities in all these markets. And the third thing that really allowed us to begin doing R&D outside of the US and outside of Europe, which were our traditional R&D centers, was the TRIPS agreement. The fact that we now have the ability to go into new regions where IP wasn't really part of the DNA of business, part of the DNA of governments in the past. We can now go into places like China and Brazil and know that for the most part the system works there, that we will be able to obtain patents from patent offices and by and large be able to protect those rights and commercialize those rights in those markets. So what really reverse innovation means to us is a move of our research operations outside of the United States and into these new markets. Shanghai in China, Bangalore in India, a new global research center that is going to be opened in Brazil in the next few months. And this is really all about a discovery that in order to sell products to customers in these markets, we really need to understand their needs. And we can't really understand their needs if we're not working with inventors who are from those markets. So, and I want to talk a little bit about two former business model that was very much used through until the last 20 years, basically called G-localization or glocalization. And for a long time, our strategy was about, okay, you develop the product for the United States and Europe, but then you got to get it to a price point that makes sense for these emerging markets. So we would strip off this feature and strip off that feature and try to simplify the product and make it and bring the price down to something that was acceptable. And we realized it just didn't work. It was not a process that allowed us to really develop products that from the very beginning should have been conceived with the needs of our customers in those particular countries. So what did we do? We moved into a different paradigm for product development. And that means we've moved into China, we've moved into India, and we have R&D teams that are developing technologies that are specifically focused for the needs of customers in those markets. So, for example, and the great thing about this is that it's a lot easier to add features to a product and to make it give it more bells and whistles than it is to take them away. And so we, for example, in China, I think I've slide. I guess I may use these slides a little bit. Yeah, we have and this is sort of a comparison. Conventional ultrasound, about 100K per unit, developed in the United States. Something that had no success in China, India, other jurisdictions like that, for a good reason. The price point just made no sense given the realities of those markets. So we put together some really smart people in our R&D labs in China and challenged them to develop a portable ultrasound assembly at a price point that would be acceptable in that market. We thought $15,000 could be an acceptable price point for certain hospitals within that market. And they succeeded. And that product has been hugely successful. In 2002, we went from a $4 million revenue to $278 million in 2008 from that product. And it sells not only in India and China and the developing world, it sells in the United States and in Europe. Because health ministries around the world are trying to cut costs. They're trying to get more for less. And so that is one example. And I know I'm not really talking about green technology here, but I'll get to that in a minute. I just was looking around for some good examples of reverse innovation, and the best ones came in our medical business. The other example that I'm thinking of is a digital X-ray that where we were selling assemblies at $40,000 to $50,000 a unit. Again, not very compelling sales proposition for our Indian and our African customers. And so we went to our R&D labs in Bangalore and said, we challenged them. We want this technology for $1,000 a unit. We want to be able to develop something that we can sell at that price point. And they did do that. And now that is having tremendous success, both in India, but also in those African markets that happen to resemble many parts of India. I mean, India is a developing country, but there are big swaths of the Indian market that look like least developed countries. So it's a pretty interesting market environment within which to develop products for our customers in the LDCs, which is really where the fastest growth is taking place today in our business. I heard some really wise comments from some of the other presenters today, and I just want to touch upon them a little bit. Vim talked about how it's about business models. It's not about IP. It really is. There are an infinite number of ways that you can exploit IP assets and use them to generate value within a company.